Hi everyone, welcome back to Nick's Visions. So, we were discussing about electrical system designing. We found out the total connected load as 682.51 kVA and the maximum demand as 341.25 kVA and the selected incoming voltage as 11 kV. If you have not watched my previous video, kindly watch it. The link is given in the description. As this video is a continuation of my previous video, it will be helpful for you to understand it easily if you watch my previous video. Now let's start the tutorial for transformer selection. In transformer selection, we have to consider two parameters. First one based on maximum demand and second one based on largest motor capacity. And whichever gives you a higher value, we will select that value in order to select the transformer capacity. Now let's start the calculation with the maximum demand. Here we have to consider a future load of 10% as mentioned in the question in order to calculate the maximum demand for the transformer selection. In the previous video, we got the total connected load as 682.51 kVA. So here the total maximum demand will be 682.51 plus 68.25 divided by 2, where the 68.25 is the future load, which is 10% of the total load. So we will get the total maximum demand as 375.38 kVA. Now we all know that the transformer has an efficiency and it is very close to 100%, but for safety we take it as 90%. So in order to select the transformer, we have to consider the transformer efficiency into the account. Then the maximum demand divided by transformer efficiency will give you the correct rating, which is 375.38 divided by 0.9, which equals to 417.08 kVA. Now this is the required capacity of the transformer based on maximum demand method. Now let's consider the transformer kVA requirement based on largest motor capacity. For that we have to analyze an equation which is K into M plus L the whole into Z divided by 7, where the K is the starter constant, which I will give you information about this later, and M is the largest motor capacity in HP, L is the base load. The equation is shown here, required demand minus largest motor capacity in kVA, and Z is the percentage impedance of the transformer, which might vary from transformer to transformer. Here for the calculation purpose we consider it as 5%. As you can see in the screen, table 1 shows the values of K for different types of motor starters available in the market. As per the given chart, the value of K for DOL is 7 and for star delta it is 2.5. For resistance and auto transformer starters it is 2. For VFD, VVF and soft starter it is 1.5. As the motor is with a higher capacity, we don't recommend DOL starters. The problem of star delta starter, resistance starter and auto transformer starters are they cause considerable power loss, especially when they are connected to motors with a higher capacity. And VFD, VV, VF starters are used for special purposes, especially where frequent speed changes are required in a system, and they are pretty expensive compared to the soft starters. So here we can choose a soft starter for the starting purpose. So in this equation, the value of K will be 1.5. Now we have to find out the term L, which is the base load. The equation is required demand minus largest motor capacity in kVA. We already found out the required demand in our previous method, which is 417.08 kVA. And we already found out the largest motor capacity in kVA in the previous chart. Here we have to consider one more factor, which is the efficiency of the motor, that is 90%. So the L will be equal to 417.08 minus 165.77 divided by 0.9, which is equal to 417.08 minus 184.18, that is equal to 232.9 kVA, that is the base load. Once we apply these values to our primary equation, which is transformer kVA, which is equal to K into M plus L into Z divided by 7, then we will get a value 380.64 kVA. The capacity of the transformer based on maximum demand method is higher than largest motor capacity method. So we will take 417.08 kVA as the required capacity of the transformer. This capacity of transformer will not be available in the market because the transformers are manufactured in certain standard capacities. As you can see in the chart, the standard capacities are 63 kVA, 100 kVA, 160 kVA, 200 kVA, 250 kVA, 315 kVA, 400, 500, 630, 750, 1000, 1250, 1600, 2000 kVA. These are the standard capacities of the transformers available in the market. Here, as per our calculation, we require transformer of capacity 417.08 kVA. So, as per the given chart, after 400 kVA, the next available size of the transformer is 500 kVA. So, we can select 500 kVA as the required capacity of our transformer. Now, the selected transformer specification will be 500 kVA 3 phase 11 kV bar 415 volt 50 Hz DYN11 ONAN indoor transformer with off-load tap changer. Here, the tap changing can be only done with the permission of local authority. The other terms and specifications are explained in detail in my blog. For detailed information, kindly visit my blog. The link is given in the description. See you with my next video on fault calculation and earthing design. Till then, bye bye.